All right, hey guys, Mr. Mandrell here. Just putting together here your first video for the Geometry A class on Edmentum for Jonesville Pathways. Just wanted to remind everybody that's getting this from the email that I sent the other day that these videos are designed to be just some basic supplemental material to help simplify a few of the topics that you should be getting from still doing the tutorials and still doing the guided notes. So you need to make sure you're doing those things so you get the full extent of the instruction for your course. And this is to help give additional instruction to that, much like we would do if we were sitting in the classroom together in the lab together. Then I would normally spend more like an hour with you guys like I did with other groups, but since I really don't want to make videos that long, since you're already listening to tutorials, we're going to try to keep these to less than 20-minute videos, okay? So that being said, I just want you to remember and realize that I am probably not going to cover every single kind of problem you're going to see on your practice or your mastery tests, okay, as far as in these videos, but it should help add some simplification to the basic topics that you should be getting from your tutorials and help assist in doing those problems, okay? All right, now I do want to start off also by saying, as you see here on my note board, my mini whiteboard here, I'm going to start with section 2. So this is in unit 1, very beginning of the course. Section 1, you should be able to do that on your own, honestly, with the tutorial that's given by Edmentum, no problem. I'm not going to do any extra thing for that. It's just on some of the history of geometry and how it started and some very basic stuff that I believe you should be able to get from the tutorial. All right, so section 2 is where we're going to start, and it is at the very basics as well. It's entitled Basic Geometric Concepts, and so we're going to start right from the beginning. When we start off with basic geometric concepts, we start off with I'm gonna get into some terminology here, or some basic vocab. Now I'm not, and I know the tutorials will give these too, but I am not going to give definitions here or anything like that. I'll probably speak the definitions, but I'm not going to write them all down for time's sake. So we start off in geometry here with point, okay? So in geometry, you have, it's like a single space or a point, a single point in space, okay? And there's really only one thing to worry about here, and that is, actually I'm not going to use an arrow, that is how do we label a point? It's just obviously a single point in space, and it usually has a letter like point A, all right, or point B or point X or something along those lines, okay? Now we also should know from algebra especially that points on the coordinate plane have coordinates. So those are like a point, you might see the directions on the coordinate plane. That's like your X and Y coordinates for the point. Like if you remember, like over 5, or like right 5, up 2. Like, so that'd be positive 5, positive 2, or something along those lines, okay? Because we have to be able to use coordinates to do geometry as well. Coordinate geometry, okay. Next would be line. And like I said, I'm not going to write down definitions, but you should know that the definition of a line is basically you need only 2 points minimum to create a line. So when we write a line, or when we draw a line, I should say, a line is 2 individual points. Let's just call this point A and point B. Okay? And then to represent a true line, the line goes through the 2 points and has an arrow on both sides. The arrows meaning going on to infinity in one direction and to the other direction. So into infinity to the left, into infinity to the right, which means that they never really technically stop. Okay, so that's a line. Now, is there really any true lines for real in real life? No, because of the fact that most lines that you deal with in geometry as it's applied to the real world have ends and beginnings, okay? So, hence the difference between a line and the next one, which is a line segment. Sometimes just called a segment. you might just hear say segment AB instead of line segment AB. So a line segment, okay, has two endpoints. All right, so when you hear problems talk about endpoints, they're talking about a line segment. So meaning that the distance between the two endpoints is what establishes the line. So this would be line segment AB. Okay, no arrows, it doesn't go through the lines, or excuse me, the line doesn't go through the points in either direction because they are true endings. And I guess sometimes some people like to think of it as a beginning and an end. It's really two end points because you can travel in either direction. You can end to the right or end to the left. They call them end points. Okay, so end points for line segments. Another thing I should mention too, before I get too far ahead of myself, is these are the pictures of these things. But how do we actually, sometimes we need to be able to write them in a sentence and we don't want to draw the huge picture. So if I wanted to like talk about or name a line, then I use this little miniature line like this, and I put the 2 points that I use to identify that line underneath it. So that's how you would write line AB. Okay? So if you're in the same thing here, if you're reading a sentence or writing a sentence, how would you label or write line segment AB? Just write a line segment instead of, with no arrows on it, and AB. All right, so that would be line segment AB, line AB. Point A, in a sentence, they'll just say the word point, or they'll just use the word point A. Okay? All right, moving forward here. The next thing that you need to be able to identify and use is a ray, and know what a ray is. Okay, a ray is kind of part segment, part line. So let's just stick with the AB here. So ray AB, a ray has one endpoint, and it has a second point that the line will travel through but not end. It's not an endpoint, so it has an arrow in that direction. All right, so this would be ray AB. Okay, now the arrow can go in either direction. It doesn't have to go left to right. But again, and then how would we label or name this? We would use a little arrow for ray. And if you wrote it in a sentence, that's how you would say ray AB. Okay. Now a ray has one endpoint, and then it goes into infinity in one direction instead of two directions. Now, could you have ray BA? Yes, that would just be going like this. So B would be the endpoint, and then traveling into the infinite direction through A, making that ray AB. Okay, so then we would label this one a little differently. We would say ray BA, because of the fact that B is the beginning, or actually, I mean, it's an endpoint, but it's like where it starts and then protrudes through point A. Okay? All right. All right, now, the next thing that usually comes as far as the basic geometric concepts is you go from ray to angles. Okay? So again, I'm not writing big long definitions here. You can get the definitions and stuff like that from your tutorial. But an angle, okay, an angle is just the combination of two rays. It's actually two rays that share an endpoint. So if I draw a point here and I draw a ray, okay, let's call this, we'll stick with A. Just make that a little easier to read. Ray A, and then we'll make this B, ray AB. Okay, so point A and point B make ray AB, one endpoint and then one arrow. And then I make ray AC down here. All right, so ray AC, same point A, but now another ray going through point C. Okay. Now, this creates when two rays share an endpoint, so ray AB and ray AC have the same endpoint, then this is called an angle. And we show an angle by the little web. I call it a web. It's kind of an arc right there. It webs the two rays together and creates an angle. Now, we don't have to have that marker right here, that little web or arc, for it to be an angle. It is an angle as soon as the two rays share an endpoint, but that's just how you label the angle. So, how would we label this angle, or how would we write this angle in a sentence? You do it like this. You use your little angle sign, and you label it usually from top down through the end point to the bottom. The main thing is that you understand that the end point, okay, or the middle point of the angle is going to be the middle letter in your label. So this would be angle BAC, because A is the middle point of the angle. Now it's the middle letter in your label. Okay, this middle point has a real name. It's actually called the vertex point. Okay, so on an angle, and I'll show over here, on all angles, okay, all right, so let's call this angle XYZ. What is the vertex point of this angle? Well, it's point Y. All right, so point Y is the vertex. Okay, so an angle has 3 points, basically 2 rays that share the same endpoint. Okay, and I'll put my little web there. All right. Okay, now moving on. I need to grab myself another whiteboard here. Okay. So what we're going to do here is on the topic of angles. You don't need to show this one now. Just to stay on that one. Okay. On the topic of angles, sticking with the topic of angles, I should say. What happens if I have 2 angles that share the same vertex point? And essentially, so that means, what if I have 3 rays that share the same vertex point, or that share the same endpoint? All right. So let's call this point here point. We'll go with point A again, and we'll make this ray AX, this ray AY, and then this ray AZ. Okay. So I have 3 rays, right? Ray AX, ray AY, and ray AZ, which makes 2 angles, because of the fact that since all 3 of these rays share the same endpoint, they create 2 angles that share the same vertex point. So the 3 rays share the same endpoint, and the 2 angles created share the same vertex point. So A is the endpoint of 3 rays, and A is also the vertex point of 2 angles, right? Okay. Now I haven't put any angle measurements in here or anything, any degrees, okay? But I can say one thing, all right? These angles here, so this would be angle X, AY, all right? And angle Y, AZ, we can say one thing, and that is angle X, AY, and angle Y, AZ are, it's like a 2Z, are adjacent. Okay? And adjacent is just a fancy word for next to. Okay? These are adjacent angles, right next to each other, right? Adjacent angles share the same vertex point. Okay? So they're adjacent angles. So if it's the same thing. It's like if you have 2 things and they add up to a whole, all right, we can usually tell what one of the parts are. If we knew what one of the parts are, then I know then I can find the other part. So, for instance, I have the big angle out here would be XAZ. If I have angle XAZ, okay, angle XAZ, so XAZ would be like the 2 angles added together. It is equal to what I just said, the sum of the smaller angle. So angle XAZ is equal to the angle XAY plus angle YAZ. Okay. Just because they're adjacent, right? So let's say that I knew XAY was 30 degrees. So I'm just substituting numbers in here for the angles. And let's say I knew YAZ, this one here, was 40 degrees. All right. Then that makes angle XAZ, the whole thing, obviously we know what 30 plus 40 is, it'd be 70 degrees. Okay, common sense there. Okay, so we just need to be able to do that. It's pretty basic, but you need to be able to understand that and use that stuff over and over again. Okay. Now, one more thing on angles before we push on here. And since this is still, again, just basic stuff, one of the main kind of angles that you will have to deal with here are right angles. Okay, so if we have two rays that create an angle, so let's say this is angle ABC, so B is the vertex point of the angle, okay, and B is the end point of the two rays. If you get two rays that create an angle that has a 90-degree angle, okay, so the little box here, okay, for those of you who aren't familiar, excuse me, instead of having a normal like web or arc, if you see a box in the corner, okay, that means 90 degrees. That's all that means. Little refresher. Probably seen this before, should have at least. It means 90 degrees, okay? All right. Now, so if you see an angle that has the box in the corner, it means 90 degrees, and that's your typical 90-degree looking angle, okay? I'm not going to move into complementary and supplementary stuff like that quite yet because it's not really in this section, but there are some other things that are, especially that have to do with 90-degree angles. All right. So that's where we are with angles. Now I want to move into some lines, okay, some pairs of lines. So I'm going to erase this just so I have some space here and some out of whiteboards. Okay. All right, we're going to go back to lines, or even line segments for that matter, and we're going to do some pairs of lines and line segments. Okay. Basically, it's this simple. If you take two lines or line segments, they're going to do one of two things. They are either going to intersect or they're not going to intersect. All right, intersect means cross. Okay, so intersecting lines. Okay, these are obviously a pair of lines. I'm not going to give definitions, so you can do that and look that up online. Intersecting lines are lines that intersect at a single point. So if I take two lines in a plane is a flat surface. So as I take any two lines, so let's say these are true lines again. This is line AB, and this is line, let's go MN. Okay, they intersect at a single point and a single point only, if they're straight lines, which these are straight lines. All right, that intersection point there, so let's just call that point C. So in this picture, obviously these two lines intersect, and they intersect at point C. AB intersects MN at point C. That's the intersection point. Okay, now this picture here, obviously the other thing you should see is, in addition to creating an intersection point, it also creates four angles, since we just got done talking about angles. Angle NCB, which is right here, and angle ACM, which is right here. And then you've got, I'll use a different color here, ACN and MCB. Okay. Those four angles are created by that picture. Okay. Now, so that's just your basic pair of intersecting lines. Now, there are a special type of intersecting lines called perpendicular lines. Perpendicular lines are intersecting lines, but they are intersecting lines that intersect in a special way. Okay. Perpendicular lines, so let's just take line segment, or excuse me, let's use line again, not line segment. Line AB Okay, and line MN. Okay, line MN. All right, so there's our same pair of lines. And let's call this intersection point, point C again. Okay, so perpendicular lines intersect, so they are intersecting lines, but in order to make them perpendicular, they intersect, and obviously they create 4 angles, but they create 4 90-degree angles. All right, so 4 90-degree angles. All right, and I kind of put my C right in the way of the brown angle here, but you get the point. And we'll use some blue for this one. Okay, so all 4 of those angles are exactly 90 degrees in order to be perpendicular. If they're not 90 degrees, then they're not they're not perpendicular lines. Okay, so now one thing that I should point out, and I'm not going to write it all down, but you should know this already from earlier math. But obviously, if I take 90 degrees and I multiply it by 4, 90 plus 90 plus 90 plus 90, that's 360 degrees. And that makes sense because if I go around this pair of parallel lines and I add those 4 angles together, it's kind of like going in a circle, which is how angles relate to circles much later on in geometry. You get 360 degrees, which of course is a full turn of a circle. All right, we know that. Like if you do a skateboard jump and you turn 360 degrees all the way around, that means you turned all the way around once. Now, if I go back to my intersecting lines picture, what do I also know about those 4 angles? Well, those 4 angles also make a full circle, right? So they all add up to 360 degrees as well. But the difference is I don't know what those angle measurements are just by looking at it. Whereas if they're perpendicular, you know it's 90, 90, 90, 90, right? Intersecting lines, they're definitely going to create 4 angles that add up to 360. But if you don't know what any of them are, then you can't really tell what they are. Okay. If I told you one of them was like 120, then you could tell me what all the rest of them were. Okay. Now, last but not least, as far as pairs of lines, because remember, this is really what we're talking about here, is just pairs of lines. If lines intersect, they can intersect this way or perpendicularly, but what about lines that don't intersect? Okay, there are lines that don't intersect. All right, and the only way to really never intersect, so I'm going to start off by calling this non-intersecting lines, is if they don't have an intersection point. Well, the only way for 2 lines to not have an intersection point when they're in the same plane or on the same flat surface, on the same 2-dimensional flat surface, okay? Because if you go to 3 dimensions, it's different. Then you're talking about in space. But on a flat surface, the only way for 2 lines or a pair of lines or line segments for that matter to be non-intersecting is to be what we call obviously parallel. And I know you've heard this word before, parallel lines. Parallel lines or parallel line segments, okay, don't intersect. So if you, it's pretty basic here. If you draw, let's go with parallel lines. Parallel lines will run on into infinity in both directions, left or right, up or down, however you draw it. So let's call this line AB and this line CD. Okay, so they run infinitely in both directions without intersecting. So they will run infinitely without having an intersection point or contacting each other. Okay, parallel line segments, all right, or just segments, parallel segments, will run to their endpoints without intersecting. And if they were to run through those endpoints, they would never intersect. Because obviously I could draw 2 line segments that never intersect, okay, before they get to their endpoints. But if they're angled in such a way that if you were to continue through those endpoints, they would eventually cross each other, well, then that's not truly parallel. Parallel means they never, ever intersect, okay? Okay, and you could have parallel rays. So you could have parallel rays that when they run on to an infinity in one direction, they stay the same distance apart and never intersect. I think that's a key point that I really didn't make earlier on, is not only do they not intersect, but they stay the same distance apart. Okay. So the other thing I needed to mention here before I get ahead of myself is how do we label these? So if we write them in a sentence, how do you, if you have a pair of perpendicular lines, how do I write that in a sentence? Well, I need to go, how do I show the word perpendicular without writing out a big perpendicular? If you see this right here, this little symbol, okay, that is the perpendicular symbol. So if you see this would be line AB, and then if I have the line excuse me. So if I read that in a sentence, that would read line AB is perpendicular to line MN. Okay? And then for parallel, it'll look like this. If I take line AB, and then I'll run 2 line segments up and down like that, and then line MN. So that in a sentence, like on a problem, you would read line AB is parallel to line MN. Okay? All right. At this point, this went quite a bit longer than I'd planned on, but I did talk quite a bit at the beginning about some of the stuff that we just needed to talk about as far as getting started here. Okay? So in the future, I'm going to try to keep this under 20 minutes. Sometimes it just requires a little more explanation. We've got a lot of the basics out of the way in this one here, and I think this will be good to get you guys started. This is pretty easy stuff to begin with. So my next one, we'll be getting into some transformations. All right, good luck, and let me know if you need help.